Good morning. Today we are going to talk about finite difference method by applying Thomas algorithm. How do these two relate? Okay, so now let's have a look on this question. You may refer to my previous video as I'm using the same question. Okay, first of all, in finite difference method, we are going to focus this equation and also this equation, y. First of all, if you see this question, you need to determine the coefficient. Now, so from this question, we know that p is 0. Why? There's no first derivative here. dy by dx of y prime x. Q is 3x. Why? Because we direct extract from here. R is 0. R is 0. There is no value there. Now let's apply this equation. What is delta x? Delta x is each step size. So this is our general equation. Later we are going to apply for I equals to 1, I equals to 1, 2 and 3. Why? Because from the time series, there is x0, x1, x2, x3 and x4. y0, y1, y2, y3 and also y4. Since y0 and y4 are known, they are both given value. So we are going to determine y1, y2 and also y3. y0 is 1.1, y4 is 0.5, and this one is 0, this is 1. So this is 0.25, 0.5, 0.75. So from this time series, we know that we are going to determine 3 values, y1, y2 and also y3. So now let's proceed. Okay, so from this equation, when I equals to 1, you get y0 minus y will get negative 1.1, because y0 will get 1.1, so we bring forwards to another side and it will produce negative. Now let's proceed to I equals to 2, x1 equals to 0.5, x2 equals to 0.5, y0 equals to 1.1. So we substitute the equation. y1 minus 2 minus 3 over x, y2 plus y. So now last but not least, I equals to 3. I equals to 3. x3 equals to 0.75. y4 equals to 0.5. Why we need this y4? Same concept apply to that, to this y0. We directly substitute the given value. See. This is the last equation. Later on, we are going to convert into matrix form. So what is the general formula? Okay, from here there is C, D and E. Why we need C, D and E? Later we are going to apply to Thomas algorithm. So D. B is the constant value, negative 1.1, 0, negative 0.5. So we obtain the answer in matrix form, and we need to convert into matrix form. So after getting all these values, we are ready to apply Thomas algorithm. Okay, B, C, D and E, the value we can obtain from the matrix that converted just now. Now, for Thomas algorithm, you need to find alpha, beta, W, and also yi. So first of all, we need to find alpha, beta, W. So we find alpha first. Alpha 1 equals to B1. So we directly abstract from here. Negative 125 over 64. Okay. BI. BI is EI divided by E1 divided by alpha 1. E1 is 1. 1 divided by this. So it's negative 64 over 125. This equals to negative 0.512. Okay, Wi is equals to B1. B1 negative 1.1 minus C1. C1 is this, minus minus plus. And then this one, you substitute the formula and then divide by alpha 1. Or you directly apply this B1 divided by alpha 1. Negative 1.1 divided by this. So you obtain 0.5632. So repeat the same procedure for the n equals to 2 and n equals to . Okay, how do we obtain this and this and this, these three values? How do we obtain? We apply this formula. Okay, now for y3, w3 is this. Okay, minus, since this is empty, we directly get from w3. Now y2, how do we get this value? w2 0.4039 minus b1 yi plus, there's a negative sign. Press your calculator, you get this value. So do the same thing also for y. In finite different method, our answer will be presented in a table form after applying Thomas algorithm, and this is the parameter we need in Thomas algorithm. By applying the formula, we can only know 4 values. but there are 8 values required. So for B, C, D, and E, you obtain directly from the equation that you will substitute all those value given. If the value is not given, you just leave it